Welcome everyone. This is our second in our two-part soil health assessment webinar series. My name is Briana Alfaro. I am the outreach coordinator at NOFA-New York, and we very excited to be doing these webinars. We've been working on this project since about May, so happy to finally share it with you all. We had our first webinar last week, and that was focused on livestock, dairy, and field crop operations. Tonight, we are focusing on vegetable and hemp operations. So please remain muted during the presentation. Presenters, of course, unmute yourself before you share. You're welcome to chat questions and we can keep track of those. We're gonna save all questions for the discussion period. We have scheduled about 30 minutes for discussion, so there's plenty of time for questions. So you can hang on to those and ask them yourselves or chat them in, and we will relay them during that period. We welcome feedback, and we will be sharing a link to our evaluation. We really appreciate the feedback, especially with this new format, doing online education. It's really helpful to get your thoughts and suggestions. We will follow up tonight's programming with an email tomorrow that'll include resources that we've mentioned and anything that comes up during the discussion. As you all know, the registration for these webinars is free. We do reserve the recordings for NOFA-New York members. So if you're not already a member, consider joining or giving a donation. And feel free to introduce yourself in the chat if you have not already done so. So tonight, after I finish going over our agenda and introducing everyone, Caro from NOFA-Mass will give us a little background information about the carbon proxy protocols. And then I will give it a presentation that gives a little bit more detail about the assessments and some of the results that we have gotten this summer while we've been doing the assessments at 6 farms across the state. And then Joseph Amsili from Cornell will do a short presentation about some of the work he's been doing with soil across the state. And then we'll have our discussion period. So let me get back to my notes here. Tonight, as I mentioned, we're focusing on vegetable and hemp production. And we have deGraff from Grindstone Farm, Matthew Leon from Lovin Mama Farm, and Paul Loomis from Growing Family Farms. As I mentioned before, we have Caro Roszell from NOFA-Mass, and we have Joseph Amsili from Cornell. So they will all be presenting this evening. All right, and we can go ahead and get started with Caro's presentation.
All right. Let's see. Just got to share my screen. Hi, everybody. I'm Caro. I am with NOFA-Mass. I'm the NOFA-Mass Education Director, and I run our soil health initiatives. And I am just going to give you a little bit of background about the carbon proxy tests and what we also call our soil health assessment program. So a little bit of history about the carbon proxy tests. The NOFA carbon proxy tests, or our soil health assessment program, were developed in 2016 by Jack Kittredge, who is our NOFA-Mass policy director, who's also the outgoing editor of The Natural Farmer. And his approach is to combine different tests and protocols from Cornell, NRCS, The Ohio State University, the Soil Carbon Coalition, Woods End Labs, just to sort of bring together a broad spectrum approach to looking at soil health. The protocols were revised in the winter of 2019-2020, so this past winter, by myself and one of our technicians, Jane Hammer, to more closely map onto the new NRCS soil health field assessment protocols that they released this past year, which just allows closer collaboration with NRCS tools and with creating some exchangeable data with NRCS. So this past growing season, NOFA New York, Connecticut NOFA, and NOFA New Jersey all received training in these protocols, and they will be using them in different ways, mainly educational, maybe some technical support going forward. And I just at this point need to drop the link to our, actually, Briana, do you have that link? I'm just remembering I need to send you the.
I just dropped the link in the chat. Yeah.
Awesome. Thank you. Sorry, the folder for our, I meant to grab that for you earlier. So in the folder that's just been dropped into the chat, that is our protocols and some demo videos and some fact sheets. Can you still see the full screen here, or is it showing the chat, the Zoom chat over it?
We can see the full screen.
Okay, great, good. So you might want to follow, open that folder and check out some of the resources in there, and you may want to follow along in the test protocols during Briana's portion of the presentation, because it might make more sense. But broadly, what I wanted to explain about the carbon proxy test, the broad goals of the carbon proxy tests are to evaluate constraints and opportunities for soil carbon storage, and therefore healthier crop and animal ecosystems, using simple field techniques that really any land manager can do. Because soil life, soil health, soil biodiversity, and soil carbon are really all interchangeable concepts. They can be seen as proxies for each other, right? But because soil carbon itself is hard to directly measure without really expensive verification methods, these physical tests give farmers a way to look at their soil without needing a soil lab as an intermediary or a carbon verification method. So NOFA technicians do offer a detailed field evaluation with recommendations, but most of the tests that the NOFA technicians do can also be repeated by farmers and soil health enthusiasts with just very simple equipment. And then broadly, just in terms of the way of seeing the soil, there's somewhat of a dichotomy, a perceived dichotomy between lab reports, which may be seen as objective, as a form of third-party record keeping, as verifiable. Let me just minimize my chat window here. As maybe more scientific, and farmer observations, by contrast, are sometimes seen as being more qualitative or subjective or experiential, maybe very specific to the land in question. And the soil health assessment approach attempts to sort of merge some of those goals so that it can be both a self-determined process by the farmer, but also have some third-party methodologies, so that it can be both holistic and quantified, so that it can be both quantitative and qualitative. And it also introduces a way for farmers to actually do record keeping around their own experiential observations. So the soil carbon proxy tests themselves are experiential observations, but we introduce a framework for recording what the farmer sees on their land, or the technician, that can then track change over time. So these are the list of the carbon proxy tests that are currently included in the protocols. I'm not going to go through this because Briana is actually going to explain many of these protocols in her presentation. So I'm just going to give you this list, and you can also find this list in the workbooks that are in the folder we just dropped in the chat. I did want to just say, though, for everyone who might be open or interested in exploring and using these tests on your own land, there's two broad ways to think about them. You can use these tests comparatively. If you're going to use the test comparatively, what you would want to do is select the different land management practices that you're interested in. So it might be, I have a field that's been under my no-till organic vegetable production for many, many years. I want to compare that with a new field that I've just recently taken out of pasture or meadow and put into production. How is my management practice comparing to a new field that's being put into production? Or a pasture versus your annual area, or a cover cropped area versus a non-cover cropped area, for instance. So in that case, you would select which tests you're interested in doing, and repeat those tests on those two different land management areas at the same time. Ideally the same day, could be the same week. for change over time, what you want to do, it becomes much more important for you to identify a specific area and then test that same area repeatedly. So for change over time, what you're looking to do is, again, select the tests you're really interested in that seem relevant to your piece of land. Choose a representative spot in your field and make a detailed map for how to find that spot again. Most GPS apps aren't going to be quite specific enough to get the location to the granularity that you're really interested in. So it's good to have like a surveyor's tape. I use a 300-foot surveyor's tape and permanent landmarks to measure from. And then I use a compass to just make a map to find that spot. And it's good to run the tests annually at the same spot in the field. You're not going to see much change over time on an annual basis usually. But so you might, shift for time and energy constraints, doing it every other year. But I think you can build up more experience with your own soil if you do it at least annually. Even more than once a year could be great if you're trying to see changes seasonally, like earthworm count is something that's going to vary seasonally. But the minimum would be test it at the same time every year. Annually is a good idea. And I just also wanted to briefly say that some of the other ways that we're using these tests are really as our own learning within NOFA, both about soil health in its relationship to these tests that we're running. So for instance, here, comparing our test outcomes when lab outcomes when they're available, you can see we've tracked in this project, we tracked our bulk density readings with the organic matter percentage on the farm as determined by a loss on ignition test. And we can see that there is a relationship between organic matter and bulk density, which is predictable. It can also be used in peer-to-peer learning groups of farmers where we'll track soil health outcomes through the soil carbon proxy tests on every farm every year for multiple years with the same group of farmers, and then actually share the results from our tests within that group of farmers. So that helps to facilitate farmer-to-farmer learning. So in this example, this is just an example of data that we collected on 6 different farms over 3 years, and we looked at the relationship between infiltration rate by different types of management practices. And this was used as a learning tool for the farmers to see what was going on each other's farms. So that's really just what I want to share about the background of the carbon proxy test. Like I said, Briana is going to go into more detail about some of the specific tests. But before she takes over, I just wanted to really encourage you to give it a try. Use the booklets in the folder that we just shared in the chat, and just take them out to your fields and start trying out some of these tests. I think they give you a new way to sort of see and observe your soil. And I hope that they're useful for you. And definitely feel free to reach out to me if you have any questions, or to reach out to Briana. So that's all I've got for you today.
Thank you so much. That was a great overview. And if you haven't clicked on the link in the chat, I'm just going to drop it one more time. I think it is helpful. Doing these presentations as a webinar is a little bit different than doing them in person and demonstrating. And so we opted not to show videos, play-by-plays, because we do have that resource available. So I recommend checking those out. And the protocol guidebooks are very detailed. So I'm just going to sort of give you brief snippets about these protocols and talk about some of the results that we saw. But yeah, I encourage for further reference, definitely take a look at those. Okay. All right, so as I mentioned at the beginning, we did visit 6 farms this summer. 3 of those we pulled into a webinar last week. This week we're focusing on what we learned at Growing Family Farms, Grindstone Farm, and Lovin Mama Farm. I really enjoyed doing these assessments. As Caro said, it just gives you a different way of looking at your soil, and maybe you've read a little bit about a soil health management practice, or tried something yourself. Using this framework, it really gives you a way to sort of put all those pieces together. So this is just a brief list. These lists here are the tests that you can do on site that don't really require any special equipment. These are all tests that you can do with either things you have around your farm or supplies from the hardware store. There are some other protocols that we won't go over today that are in the guidebooks that you can access yourself as well. You just, they're more specialty kits that you have to order, but definitely take a look at those. So yeah, I will go ahead and get started with the first farm. We'll start with growing family farms. Paul, are you there?
Yep, I'm here.
Awesome. So Paul was having trouble with his camera, but he is here. Do you mind introducing yourself and telling us a little bit about your farm?
Sure. So I'm Paul from Growing Family Farms. We do a no-till, or I guess low-till system. Actually, the beds we're looking at are probably like 2-3 years into no-till system. We use wood chips inoculated with mushroom spawn in the paths, cover cropping. So basically, we use veg and hemp, rotating the beds each year. So 1 year, one bed will be in hemp, the next year that bed will be in veg, and then early season veg goes into cover crop, which we see here is a multi-species mix of cover crop here, Sudan grass, vetch, clover, a couple other things. So that's kind of a rotation that's kind of new to the game as far as what we're doing. So yeah.
All right. And I forgot to mention, Paul did participate in the soil health specialist program. So he maybe has a little bit more background information. So it was really great to visit his farm and see the practices that he's put into place. Do you want to tell us about any soil health goals that you have?
Yeah, we're basically in a glacial deposit south of close to Lake Ontario, and our soil is very sandy, so organic matter and nitrogen are super important nutrients for us. So you know, we've continuously tried to do this. Like this field here is on rotated chicken pastures, so we're rotating egg layers. We bring in a lot of organic matter, a lot of carbon from off-farm sites, and as well as trying to also bring some through cover cropping and you know, just general rotations.
Awesome. Thank you. All right, so the first protocol that I'll share is surface biology. And this is one that I like to start with. It's really just, you know, observational and analysis, looking at the surface. So once you pick your site, and Caro mentioned a little bit about how you might pick your site depending on your goals, the goals of your assessment. So this site we chose was a row where Paul had planted a cover crop mix. And so as you can see in the photo, we take a hula hoop or something the equivalent size of a hula hoop, like a string, and place it over an area in the field that is representative of the growing space. And then you take a look at the different species, the grasses, broadleaf plants, insects, any of the biology that you can observe, and you note what it is that you're seeing through approximate percentages. And then you also want to know how much bare soil you're seeing. And the idea here is that the diversity of ecosystems is an indicator of resilience, landscape health, and may also give you clues to how your soil is changing over time. So at Growing Family Farms in this particular spot, we observed about 34% bare soil, 1% plastic mulch cover, 65% living cover, which was made up of vetch, buckwheat, clover, oats, alfalfa, purslane, galansoga, and dandelion. And then we also observed 2 ants and some mycelium. And the next protocol that I'll discuss is digging a hole. And if you are looking at the guidebook or when you look at it later, you'll notice that digging a hole is actually a number of assessments broken down into a few different parts. So for this, for Growing Family Farms, we dug the hole, and this is one of the slices of soil that we pulled out. And I think as Caro mentioned before, some of these, I would say, once you practice these assessments, they become a little bit less subjective. But this year, since we were learning these protocols, they were new to our staff. I would say that a lot of these, we're still, you get better at classifying these with practice. So in this case, we looked at a few different sections. The top 1 to 4 inches, the 4 to 8 inches below it, and then 8 to 12 inches deep. So we found the first section to be silty clay loam, the middle section silty clay loam, and then the lower section to be silt loam. And the way that you do these is through NRCS fieldbook protocols. As Caro mentioned, a lot of these protocols are pulled from, they have other origins that have been pulled together into one comprehensive little guidebook. And so the texture by feel, you literally take soil and wet it and put it in your hands, and you follow along sort of a decision tree until you come to a classification that makes sense for your soil. And I would say that the texture is a really good place to start and to understand because it sort of influences a lot of the other a lot of the other characteristics of the soil and your soil health. So I would say that's a good one to become accustomed to understanding. Another protocol that we assessed at Growing Family Farms was looking at earthworms. And so for the earthworm count, earthworms are a good indicator of soil health. So I think it's definitely worthwhile to take a look at. In this assessment, you take the soil. So after you dig a hole, you reserve that soil. And the reason you observe it is because you're going to go through and count all the earthworms that are within that soil. So you'll sift through it and you'll count any earthworms. And then the other part of it is that you'll look at inside the hole for signs of earthworms. So in this case, we didn't count any earthworms in the soil that we dug out, but we did see evidence that there had been earthworms there. So we did count 10 burrows, or they're also called biopores. And that brings up another good point, that this summer was a very dry summer. And so earthworms in particular aren't going to be as prevalent, in the summertime. So I would be interested to do this protocol again in the spring at the same farm. And I'm pretty, confident that we would see worms there. The third assessment that I'll discuss with the Growing Family Farms data is root behavior. And this is another part of digging a hole. So after you dig the hole, some of the things that we look at are topsoil depth and also aggregates and root behavior. So we observed that the depth of the longest root went all the way down the full foot depth of the hole that we dug. And the majority of the roots terminated at about 6 inches. We found 90% of them were branched with root hairs and 0% of them were sideways or balled up. And rhizosheathing, which is any aggregates that attach to roots. So what we did is we pulled out a chunk of soil that had roots attached to it. And the rhizosheathing is the aggregates that stick to the roots, which is an indicator of good soil health. And so we found that the rhizosheathing was strong. And another part of the assessment is to take the chunk of soil, the roots that you pull out, and you drop it, and then observe how many of those aggregates actually held on to the roots. And so we found that about 30% of the aggregates held on to the roots. All right, so that is all I have to share from Growing Family Farms. The next farm that we will take a look at is Grindstone Farm. Oh, and I just got a note. I think I maybe don't have the right screen share. I had a feeling that maybe the little sidebar was showing, so I'm just going to fix that real quick. Okay, maybe I'm not going to fix that because it's not, I can't figure it out and I don't want to take up any more time. I apologize.
I think if you go to view in Adobe and then do full screen mode.
I know, but it's not letting me click on any of that top bar for some reason. I can see it, but I can't click on it. So actually, let me just try closing it out and reopening it really quickly.
And we'll have time for Q&A at the end, folks. So if you have questions as we're going along, feel free to just drop them in the chat.
All right, I think that worked.
There you go.
Okay.
Looks good.
Thank you. All right, we have deGraff here. Please tell us a little bit about your farm.
Okay, can you hear me?
We can.
Okay, we're located in Oswego County. We also are close to Lake Ontario. Our soils run from silty sand and some clay up to boulders the size of VWs. So this particular field that we chose is a sandy, I would call it a sandy, silty loam field. It was actually a field that we did not plant until a little bit later. We had it scheduled to plant in August. I'm not sure when you guys were there, but it still wasn't planted then. As I look at it, I see a bunch of small weeds and things like that. But we chose it just because it was easy to get to and it had some diversity, etc. So, but typically our crops are blueberries, asparagus, and then we do a lot of summer vegetables, squash, greens, and things like that. So we're pretty diverse. Our market is through our online, our website ordering. We do home delivery and we also do some wholesale sales. So I have been here for 39 years now. I will admit that I'm not a soil scientist. I also claim that I'm not really a farmer, but I'm just trying to make it happen. So anyway, I'll be happy to answer questions later if there's questions arise. we'll let Briana and everybody do their thing. So.
Thank you. Did you want to mention any soil health practices and or any soil health goals?
Obviously, I'd like to get my soil to be a little bit better. We have been using every chance we can. We incorporate as much compost as we can, which everybody knows is expensive, and a lot of trucking and things like that. We have been using different minerals. Chicken manure has been, from Cryers, has been one of my go-tos, so to speak. We have started mulching a lot of our crops heavily, if we can, using old hay, big round bales or bales of hay for, you know, as many crops as we can. But other than that, yeah, I feel like my soil is always weak, and I always look for different ways to try to bolster it or make it a little bit better, because I know that that's, you know, we aren't going to make it without good soil. So that's about it.
And when we were here, we did choose this field, I think in particular, just feeling like maybe it wasn't, if I recall correctly, Dick, that maybe it wasn't doing as well as in the past. So maybe like a little bit of troubleshooting. And we did do a comparison with an adjacent field as well, in an asparagus patch field. So I'll go over some of those results.
That is correct, yes.
So we dug a hole at Grindstone Farm, and we found the soil type to be sandy loam. So again, we did that texture by feel using that in our CS chart. We looked at roots. We found the depth of the longest root to be 12 inches. The majority terminated at 5 inches. 0% were branched with root hairs and 0% sideways or bald. We found rhizosheathing to be moderate to weak, and 40% of the aggregates held onto their roots when we dropped our sample. We also did an infiltration test. So I will tell you a little bit about the infiltration protocol. So this protocol shows how fast water sinks or absorbs into the soil, and it's an indicator of biological activity and healthy soil structure. We look at how long it takes an inch of water to absorb into the landscape. Compacted soils, even with plants growing, take longer, while biologically active soils can be anywhere from a few minutes to a few seconds. So we did the infiltration test twice at Grindstone Farm. Test site A was the field that we mentioned before, annual vegetable fields. We were looking to do like a little bit of troubleshooting there. So this photo was taken from that site, and it took about 3 minutes, 24 seconds for that 1 inch of water to infiltrate. We did this test a second time in the adjacent asparagus field. And just for comparison, we found that the infiltration, it took 27.43 seconds for the same amount of water to infiltrate. So for myself, this was really such an educational opportunity to see the difference between annual and perennial, just the difference in those systems and how that affects water infiltration.
This was really only about 30 feet apart from each other, I believe, correct?
Yep, they were really close to each other. And another test that we did at Grindstone, I took these samples for a slake test and then assessed them at home, which is why the photo is taken inside. So the slake test, I haven't gone over yet, so I'll tell you a little bit about that. So the SLAKE test is based on work by NRCS and Washington State University. The purpose is to observe the maturity of aggregates and resistance of aggregates to erosion events and to compare management practices on your land. So we took one soil clod from the test site and we took one soil clod from the adjacent site, the asparagus field, and we placed each clod into a wire mesh basket and submerged them both into water. And then we watched to see which soil holds together and which soil clod holds together and which falls apart. The soil with poor structure is the one that will begin to fall apart. So you can see a little bit of difference here. The one on the left is from the vegetable field. The one on the right is from the asparagus field. So you can see that on the left that the water is a lot less clear. It's a little bit more murky. And then on the right, the aggregates are a little bit more stable. The water is a lot more clear and there's a lot less of the soil resting at the bottom. And we found that 88% remained in the clod on the test site and 98% on the comparison site. So next we will take a look at Lovin Mama Farm. All right, Matthew, are you still there?
Yeah, I'm right here.
Awesome, thanks for joining us. Tell us a little bit about Lovin Mama Farm.
All right, thanks everyone for joining us. My name is Matthew Leon, and Lovin Mama Farm is in Amsterdam, New York. We farm about 2 acres of organic, no-till vegetables and flowers, and some microgreens as well. We go to farmers markets, 2 farmers markets, and we do mainly, that's our main source of income, and we do some wholesale as well. And we just launched an online store this year in response to the pandemic. And that's how we sell our food. And yeah, like I said, we do a no-till method, which is heavy on compost addition, similar to Singing Frogs Farm in California. And basically, as far as our strategies for maintaining soil health, you know, it's to keep crops growing in the ground as much as possible, keep active roots in the ground, and add good compost so that your tilth is really good and you have good healthy plant growth, and to mulch with some sort of living mulch if possible. If not, then some other type of mulch to prevent weed growth and keep the worms protected down underneath the soil. And let's see, what was the other one? That's basically a little bit about us.
Awesome.
Yeah.
Yeah, and I just want to note that this this farm was sort of, you know, we have the different zones, and I think part of the reason why we chose this zone was because it was the one that had been in production the longest. So taking a look at that field. And did you want to share any soil health goals?
Yeah, really for us, it's to take a heavy clay soil. I forgot to mention the parent material. It's a pretty heavy clay soil that we're growing on. And we saw some definite signs of like too much moisture during heavy rain events. And so by building up on the compost on top of that soil, we're finding that the plants are able to get enough air and not get too waterlogged in heavy rain events. So like I said before, mainly it's just keeping crops growing on the soil, keeping your soil covered as much as possible and disturbing your soil as little as possible, and not inverting the soil, which brings up weed seeds and the subsoil, which tends to not be as good as the topsoil. Yeah.
Awesome. All right. And the last thing I'll note before I get into sharing the data is that we did do a full-on field day at Lovin Mama Farm. And again, that is in the member content area. If you are a NOFA New York member, you have access to the recordings. And you know, they're there indefinitely. So at any point that you want to join, if you are a current member, that was actually one of my favorite field days that we did. And so there's a lot of information, especially about no-till and their operation, if you are interested. All right, so we looked at the surface biology and the area that we chose had recently was in the process of being flipped. So that's, I think, in part why there's so much bare soil. We found 85% bare soil, 15% living cover, which was made up of purslane, an unidentified weed that I don't think we ever got to the bottom of as far as figuring out what that was. I'll have to look at some of the photos a little closer. Dandelion and an amaranth. And then as far as biology aside from plants, we found 3 aphids. So we, as far as digging a hole, we identified that there was about 3 inches of topsoil. And then we also did an earthworm count, and we found 10 worms and we found 44 burrows. So there's definitely evidence that at one point there were a ton of worms there. We did do this assessment, I believe it was the end of July. So it was very hot, very dry when we were visiting this farm. We also performed the slake test at Lovin Mama Farm. We took a clod, in the photo on the right side is the clod that we took from the test site. And then the clod on the left was taken from an area that was not in production, sort of an adjacent field area. So we found Site A, which is the clod on the right in the photo, 90% of the clod stayed intact after it was submerged in the water. And the comparison site was closer to 97%. All right, so that is actually the last slide I have for this portion of the presentation. That is the data that I've selected to show. So we are a couple of minutes ahead of schedule, so I'm happy to take like a question or two. If anyone has any questions about like the specific protocols that we're showcasing, we can reserve the questions for like management for the discussion period. But does anyone have a question about any of the assessments that we performed?
I have a question for Paul Loomis.
Okay.
Paul, how do you deal with the residue from the cover crop in the beds? I mean, how do you terminate them and get them to do what they need to do in the soil?
This voice sounds very, very familiar.
Well, it could be Eddie Rapi though, you know.
Okay, Eddie Rapito. All right.
All right, yeah.
Okay, well, so we do use a lot of tarps, so we would probably chop the crop, you know, whether it's with we have a flail mower for a BCS or just a weed whacker, drop the crop on the ground and cover it for a week or two, depending on the seasons. Like it can be really quick in July. And when you pull the tarp up, it's kind of amazing how beautiful the bed looks. It looks like it was just tilled. Depending on the temperatures, though, like it's not going to happen right now. It's going to be a lot slower. But even if you get some of the silage tarps and you can cut them down to your bed size.
So you're using occultation as opposed to solarization, or you're using both?
I use both. I use some, in June, July, we can really burn out grass with some clear plastic. Some of the old greenhouse covers is what we'll use for that, and just to bring some new ground into tilling. But the silage tarps work well in that respect, or maybe just if we were using like clover, we could pretty much chop and just plant into it, depending on what the crop was.
Okay, great, thanks.
All right, we can probably take one more question. If anyone would like to. All right, so we will go ahead and proceed. Joseph Amsili has been helping us with this project. He visited some of the farms with us, sort of has been adding his expertise. And he has been working on this project, analyzing soils, which I will let him describe to you. So without further ado, it's all yours, Joseph.
Well, it's great to be here, everyone. I'm just dropping the links to these reports in the chat box, and then I'm gonna go ahead and start sharing.
Love your backdrop, Joseph.
Thanks. All right, so here we are. This is just to let you guys know that these reports are available in the chat box. And yeah, it's great to fit this in with this great webinar series. It's maybe a more macro view of soil health in New York State, and looking at what some lab results tell us at the state level. Got to acknowledge New York State Environmental Protection Fund. It's coordinated through New York State Department of Ag and Markets. But yeah, I was going to start with this picture to just get us thinking about the differences. Well, let me back up. Basically, what we did was characterize soil health across New York State using about 1,500 composite soil samples from all over New York State, and we had some soil texture information and cropping system information. So if we think about kind of what we're thinking about when we look at think about different cropping system influences on soil health, you can think of kind of what a natural system is like, pasture, grassland, where basically all of the biomass being produced in that area is being returned to the soil. There's no disturbance through tillage, which keeps the soil structure intact, living organisms intact, protects the soil organic matter. And we can think of, on the other side, kind of cash grain or commercial or processing vegetable operations, which are pretty large in scale, where we're harvesting about 50 to 70% of the above ground crop biomass and maybe only returning 30 to 50. And then these conventional farms, which is the reason, one of the big philosophical and important parts of organic is making sure to counterbalance this harvest of organic material with organic matter inputs. We're also in tillage systems, we're oxidizing the soil, and when we're not covering it, we're getting big erosive losses. And then intermediate between these systems and our dairy cropping systems, which can have perennial forages, more manure inputs, and mixed vegetable systems, which we chose to contrast this larger scale processing veg, is basically the smaller scale organic vegetable farms, you could call them, which are using a lot of compost and cover crops, And some at this scale, like Paul and Loving Mama Farm, are maybe even can create soils that are even better than they are naturally, because the scale is so small that you can really really change the soil through organic matter amendments. So what we basically found, I'll just show a couple indicators here, but this is basically showing that these pasture and mixed small scale organic and mixed vegetable systems, and because soil texture also plays a really strong role in how much organic matter a soil can hold. Soils with more clay naturally hold more organic matter than sandy soils. So we did this comparison within texture groups, just so we're comparing apples to apples. Dairy cropping systems may be intermediate, and then these annual cash grain systems are cash, and processed vegetable systems are more intensive. In aggregate stability, I guess maybe what we saw in deGraff's field as well here. So these pastures, these undisturbed systems that have this intact living roots and their associated mycorrhizal fungi, which are really key players in helping build and maintain these aggregates, always have the best aggregate stability. And you could pretty reliably do kind of a comparison of maybe a pasture sod right next to a tilled field, and you might not get as dramatic a contrast as this, but that tillage versus undisturbed is really what creates this. And what we found also is that systems that maintain more organic matter can help increase this organic matter. So your compost additions are helping to also increase aggregate stability. This is pretty consistent over all the soil samples. Pastures having the greatest soil health, and these processed vegetable and grain crops having the lowest soil health. And basically the insights, we've known for a while that soil texture influences the amount of organic matter a soil can hold on to. But I guess what's more new and what's really a more important part of this report is showing the effects of these different cropping systems that have these different carbon and nutrient cycling and soil disturbance regimes on soil health. And that maybe we can have some new metrics and aspirational goals and targets for different production environments. So we're not unfairly comparing a 2-acre system to a much larger system, and giving everyone, basically allowing people to compare to who their cohort is, both soil type and cropping system wise. So that's pretty much all I got. Happy to take any questions.
Does anyone have any questions? Well, I encourage you to take a look at the reports. I found the technical report to be really interesting, but the summary report is a little bit shorter. Both of those links are in the chat for you to access, and we'll be sending them out with a follow-up email tomorrow as well. So we have reserved the rest of the time period for discussion. I do have some questions, but I think that we do have some, sounded like we had some questions coming in. So I am happy to take your questions first, and they can, they can be questions for Joseph, Caro, or any of the farmers or any of the NOFA staff that is also here and has participated in these assessments this summer. So if there are any questions, feel free to unmute yourself. I think we did have a question that came into the chat, but that was already answered, I believe, in the chat by Caro. So thank you for that.
Well, only partially. I'm interested in whether Timothy had more questions about that. I answered just sort of based on the farmers, how they had self-described in the slide that I used. But Timothy, I wasn't sure if your question went to trying to get to a shared common definition of min-till versus no-till versus tillage, or if you were asking about my slide specifically.
Well, it came up based on your slide because there was some data in one of the graphs, but and it's a huge question that'll be very difficult to come to some shared agreement on, but I'm just trying to see examples to learn from of, someone who says, well, I'm doing no-till with, mixed vegetable crops. Well, what are they actually doing? And so I'm always looking for people to share what they do when they say they're doing no-till or light till.
That's a great approach. Yeah.
And your answer was great. I mean, that's helpful, but just talking to more people, that's what we have to do. Just keep the conversations rolling.
Exactly. And I think the framework of tillage reduction can be helpful in this context because when we talk about tillage reduction, we give people the room to start where they are and just be creative and think about ways they can remove tillage from wherever they're starting. One of the things just to say quickly is that we will have a report coming out this winter based on some soil health surveys that we are doing. And I'll actually drop a link in the chat shortly to that survey in case anybody on this call would like to fill it out. But one of the questions we ask farmers who are filling out that survey is, how do you define no-till? And so that'll help us to start to sort of build a sense of what are the variants of the meanings that people ascribe to that term.
And that survey has been distributed across the region, right, Caro?
Yeah, so that survey is being put out by all NOFA chapters and also some affiliated extensions that we have relationships with, like UMass Extension. And we have, I think, 80 responses or thereabouts, and we're shooting for 100 before we start writing that report. So I'll drop that link in the survey shortly, and anyone who can help us get close to our 100 target number would be great. It's just with the caveat that we're looking for only practicing farmers to fill it out.
Awesome, thank you. All right, so we have a question in the chat. How might the insights gleaned by these studies inform state policy or federal farmer incentive / grant programs, i.e. direct payments to farmers for soil health practices?
Well, I guess maybe I could answer, since some of the data from the report can potentially be useful for policy and just making goals. It's looking like, yeah, this is maybe one of the first big statewide data sets that can be used to help make targets or aspirational goals for different soil types and cropping systems as a starting place. So I guess, yeah, that's maybe one answer on my side.
Caro, do you have anything to add to that?
Yeah, I mean, I don't want to fully answer that question until we've actually had time to analyze the survey results, but I can say that one of the early results that we're seeing, one of the things we were kind of trying to tease out in the survey is how do farmers value different approaches to programming, such as an on-farm soil health field day, obviously not possible right now in the context of the pandemic, but generally, compared to like a more traditional workshop or versus like a technical assistance coming out and giving an evaluation. Where is that technical assistant coming from? Are they coming from extension? Are they coming from more of like a farmer to farmer network organization? Are they coming from, is that technical assistant actually a commercial farmer who's being paid for their time? So what different types of technical assistance and educational formats are most helpful for growers? And we are seeing that there is a preference, at least within our survey, for farmers, actual commercial farmers, to be paid for their time to support other farmers, and for peer-to-peer formats for education. A little bit of a preference there over sort of like extension or other more like agronomist-based advice. And I think that's a lot of that has to do with partly just with the fact that it's being distributed through a NOFA channel, right? So we're a farmer to farmer network. But also I think it does reveal sort of this desire in the farming community for solutions to be couched in sort of real practical experience, right? So we'll be talking about that a little bit more informed way after we've had a chance to analyze our survey. But that didn't address incentives, but incentives was one of the things we looked at, and we are seeing that there's a stronger preference for education than there is for payments.
Awesome, thanks for sharing. All right, so I am going to go to some of the questions that our staff has prepared, and these.
Hey, Briana, could I ask a question?
Of course.
So I understand kind of on a practical basis how this could be a great set of tools to do comparisons from one field to another, or look at over time and just develop a better sense of assessing soil health on my farm. But and I also know, that this is not the objective test that a lab would do, but it might be in the data that you posted. But without having seen that, could you just talk a little bit more about how does doing these kinds of this set of tests on my own compare to, say, the results I get from the Cornell soil health test? Like, is the right approach to do both, and then to save some money on kind of an annual basis by just doing my own, and then doing like a more formal objective test every 5 years instead of every couple of years? Or could you talk a little bit more about the relationship between the objective kind of soil test, like the cash test, versus this kind of testing?
Caro, I see you nodding, and I think this question also came up in the last webinar. And so yeah, if you'd like to go ahead and take that question.
Well, I'm going to give someone else the opportunity to give their thoughts, but I'm also happy to give my answer. Well, I'll just say I think that the Cornell test is a really valuable test. I think that what our goal is with our project is to sort of the tests that we do, we'd like them to be repeatable by the farmer, and for the farmer to be able to be empowered with the knowledge and not necessarily have to rely on mailing off soil to a lab, which I think it cuts down on the intimacy of the observation and the empowerment of the farmer to learn to use these tools as a direct observation framework, if that makes sense. I think that doing the Cornell test is a great complement to this, or doing your standard lab test, because you're going to get cation exchange capacity, and the Cornell test in particular is a really nice breakdown of your soil texture, specifically with percentages, which is really handy. And you're going to get much more accuracy, right? But I also think at the same time, there's a lot to be said for learning to get to know your own soil through these methods. I'm curious to see what Joseph, how you might respond to that same question.
Yeah, no, I think you're right on. And these, I mean, there's no replacement for taking a spade out and getting to know your field, because if you can't really see a difference or observe a difference, then there's no reason to try to test for the difference. So I think having really good questions going into the cache testing, which is a much more expensive soil testing because you're testing a lot of things, having good reasons for doing that is really important, so that you get the most out of it. It's not quite the exact same kind of tool as a routine soil sample that you'd send in, that a lot of people do grid sampling and more detailed sampling to kind of get the average of what's out there. For the cache testing, you really want to think about your question really well, so that you can get the most out of, and that really starts with knowing your fields and knowing your soils and experiencing them. And digging a hole is a great way to start that.
The other thing the cache test will give you is a soil health score. I think that, right, Joseph, you guys are using data for the range of farms in that soil type, right, within your data set, to sort of give the grower a score. And that's not something we do. With our tests, we'll describe what we saw and then sort of make some recommendations for the constraints that we saw. But I think the Cornell test, you guys do that, but you also provide that score, which is really helpful.
Yeah, it's nice to, and the more data we get, like now in New York, now you can see how your data compares to your cohort on the same soil texture, same soil type, and same cropping system. So you can get a more sense, okay, I'm at the 75th percentile, meaning that I'm one of 25% of people in this system that's doing this well. And that kind of information, I think, is helpful for knowing what's possible within your system. So.
Hey, so I wanted to throw in a little, if I could. I think from a farmer's perspective, the tough thing about soil testing is that it can cost a lot of money to get to know your soil well enough that you know what to do when you're trying to farm and grow a crop. The nice thing about what you covered here is that it's all tested, like you said, that we can do with tools that we have available, and it doesn't cost money really for us to do it on our own. So it seems like when you get into a field and you're unsure about what to do, how to fertilize, how to take care of that field, you kind of have to do one soil test at least to just get an idea of what the chemistry is. Because you can test the soil physical characteristics like you just covered, but you'll never be able to tell what the chemistry is doing without that lab test. So it seems like, though, you can use the digging to get familiar with different places on your farm that you're thinking about doing cropping, and then you can start to see the soil type where they are, where it's one soil type and where it's a different soil type. And then you can actually, in the future, once you start to see those patterns, you can carefully test lab tests from each of those different soil types so that you get an idea of which soil type has what sort of chemistry and situation with the nutrients in it. And then you can respond and try to hone in your soil balance really well.
I think that's really well said. Yeah, and I want to be really clear that the carbon proxy tests or health assessment are not a replacement for a chemical lab analysis at all. And we really recommend folks do that alongside. The idea is just to sort of provide some sort of structure and some of the qualities that we look for in a lab analysis to farmer observations by making them a little bit more structured and a way to keep records of them, things like that. But really the goal of the soil health assessments is to identify things like a plow pan or root behavior that indicates that there's a problem, or structural issues like, for instance, a no-till farm that I work with uses a power harrow quite a lot. And we, through our soil health analysis, we were able to identify that, hey, you've got some real serious soil structure problems in the very top of your soil. You have much better soil structure at like 4 to 8 inches. So maybe like find ways to reduce the power harrow, because you're sort of developing this, like you're getting towards getting like a crust and some issues on the surface of your soil. So just the ability to start to learn to identify these soil health constraints, which are different from your soil chemistry constraints.
Yeah, I just want to add that I think that they complement each other. Like you can see a lab result and it might seem like a little bit abstract to you, but when you put your hands in the soil, you can sort of and look at a lot of these indicators. At least for me, it helped make some of the connections and to understand and like make a better informed decision about like how to proceed. So I think that in a nutshell, I would say they complement each other. Do any, Paul or Dick, did you want to add anything? I'd be interested to hear how either of you are what your thoughts are on this and how you might be using these proxy tests in the future. Was there any one in particular that stood out that seemed really useful to you?
Well, I mean, I was kind of impressed with the water filtration one that you guys had done, because seemed like it took forever for the one to go through and the part that we tilled, but the other part was just immediately gone. But yeah, I mean, and I agree. I've been negligent in getting the chemical analysis of my soil for a while. And I mean, now we're working on it a little bit more. But I've always tried to look at the tilt of the soil. Yeah, I've gone out with shovels before, or when we were doing the penetrometer. I mean, that was one of the things, you had the penetrometer there and we couldn't push it in on the part that was tilled, but we go to the untilled part or the asparagus, man, it just sunk right in, like just by setting it there almost. So, I mean, that's a pretty good indicator right there of health and tilt as well.
Awesome, thank you. Paul, do you have anything to add?
Yeah, I mean, I think of it as a balanced diet. You know, we have to look at every piece of it. Of course, you know, looking at our micros, our macros in the soil, especially if we're growing high value crops, you know, such as, you know, greenhouse tomatoes, you know, peppers, stuff like that, where, you know, it's going to be worth that $100 to do the test for, you know, whatever X amount of dollars you're going to pull from the crop. And I think that's how we look at it. From a general sense of the field, it's great. You should know every piece of your field, what soil grows like this plant better, this, you know, what's part of your field grows this better, you know, looking at, you know, sunset, sunrise, there's a million things we look at when we grow, and that's becoming a good grower. So, you know, if we're looking at soil structure, and we can just see, it's very simple to see, do we need organic matter? It doesn't take a rocket scientist to say like, yeah, you know, maybe we got to fix this issue here. And also too is like, there's also tissue testing too, and that's a real-time test of like where your plants are. You know, a simple micro like manganese can throw off your plant. And I think when we really start to dial in growing specific crops, we have to really look at how we're doing it in general. I mean, the reality, and this is from American Farmland Trust and going through that program, is soil needs to be covered. You know, we need the infiltration of water. We got to maintain the topsoil, you know, and those roots are carbon. So, you know, if you get one thing from this, you know, I would say that would be it. You know, is keep a good, whether it's crops or cover, or even a tarp is better than nothing. So, yeah.
Awesome, thank you. We had another question come in through the chat. Do the technical reports acknowledge that the concepts and practices of farmer-led soil observation / categorization are largely derived from peasant and indigenous farmers? They do not currently, but that raises a really good point. I actually wanted to do a little research on that in preparation for these soil webinars, and I did not get a chance to, but that is something that I want to work on for the coming year, because I think, like, for me, a lot of these assessments, I just thought, like, people have clearly been doing some of these things for years. You know, it's like a lot of these things are very intuitive once you start doing them. There are some soil test, there's some background information. If you all have looked at Farming While Black, that is one resource that I found that has a little bit of information that uplifts the story, the traditional uses of, oh, awesome. Thanks for sharing that resource. And yeah, so I have been looking at some of the resources that are available and haven't found a lot of attribution there, but that is definitely something that I'm working on as far as next year bringing our soil programming forward. So thank you for raising that point. But Caro, I don't believe that I have found anything in the materials that we've been working with that include that history.
Yeah, no, it's a great question. You know, Jack Kittredge, who is the original drafter of the protocols, like I said, drew them from Cornell, from the Ohio State University, from NRCS, and that was, so it acknowledges those origin points, but you're right. I'm sure that they derive from other places before those institutions. So that would be a really important thing for us to look into. That's a really excellent point.
Yeah, and I think there is a little bit of that as well in Soulfire Farm did a 3D series on all different topics, and their soil 3D video also includes some of those stories as well. So those are some of the materials that I've been gathering to start incorporating into this programming. So yeah, thanks so much for sharing that, the MESA program resource. Does anyone have another question that they either want to unmute themselves for or put in to the chat?
I have a question. So I've been using a little bit of wood chip because we've had a couple of piles that were delivered to us. And the way I'm using it is putting them in the wheel tracks pretty much. But one pile that had been sitting around for a couple of years was fairly nicely composted. And so I've used that on the bed and on a couple of my beds, you know, right on top. And they'll be lightly tilled in later, probably just scarified basically next spring. But does anybody else use wood chips, and you actually use it directly on the beds, or you know, incorporate them right into the soil, or are you doing what I'm doing and just basically using them in wheel tracks?
I can answer that a little bit in that I've used them both in the wheel tracks and on the beds. But I find that putting them in the wheel track seems to work pretty good. And then they eventually get incorporated, but I kind of do it more in my greenhouse because that way we don't track it all over the farm, you know, out of the greenhouse, because we go from the greenhouse into our office or whatever. So, but at the same time, you know, it seems like they rot down pretty well, and just, you know, eventually you don't even see them anymore.
Yeah, we also use wood chips. We've mainly been using it in our perennial plantings. My knowledge of soil biology tells me, you know, through Elaine Ingham and, you know, other resources that, you know, you have in general your annual crops that want like more of a bacteria dominant soil and less of a fungally dominant soil. And then you get your bushes and vines that want a little bit more fungally dominant. And then you have your like tree crops that really want a more fungally dominant soil. So depending on the crop that you're growing, you know, I would put more or less wood chips in depending on that. They also, when added fresh, can leach nitrogen from the surrounding area and can starve your crops and create a slightly more acid environment, I believe. But those are, I think, mainly in the short term, and over the long term, those effects won't be the same. And so when you talked about the old wood chip pile that had broken down a lot, my first thought was that, I mean, what happens when mushrooms fully digest wood material? They leave the longest lasting carbon in the soil possible, I believe. There's 3 types of humic substances. They're known as humus, basically, or humus, depending on your, I think it's humus though. But they're really amazing carbon for your soil. So adding the fully decomposed wood chips should be a great thing for your soil because of that.
Sure. And yeah, because I do put wood chips around the apple trees and things like that, you know, that have not been composted. But you did mention vining crops, that it's good to maybe use them uncomposted in vining crops, did you say? I didn't quite catch that.
I mean, you should look into Elaine Ingham, and, you know, I think she has some materials on the Soil Food Web website that might help with this. I'd have to look into it too. But I know that what she had said that I had learned was that, you know, yes, the vining crops and the bushes, I believe it's more of a 50-50 fungally dominant to bacteria dominant soil microorganisms in the soil there. Whereas trees like even more fungally dominant. So like more like 70 fungally dominant and 30 bacteria or something like that. But your annual crops want less wood chips in general, I think.
Right. Okay. Wow. Thanks. Yeah.
Anyone else have anything to add?
Yeah, I would agree with pretty much what Matthew and Dick said. You know, new wood chips can be a nitrogen robber on crops. So letting them sit for a while or taking they call Remino wood chips as the new growth on the trees when they cut like the power lines in the beginning of the year. It's that there's a hormone in the growth, but for sure that you know, we actually inoculate our piles with King Stropharia mushrooms. So now we're going to get that mycelium chamber within the beds. So if we're putting, you know, some wood chips that we've let sit for a year and we've already inoculated that pile, and now we have a heavy mycelium balance in that pile already, and now we can put those in the beds. And so any of that carbon that lays down from a cover crop can now become, you know, more easily bioavailable, you know, for the plants in the future. Whether it's like, you know, we never pull plants from the ground, like ripping them out by the roots. It's a cut. And then, you know, includes like peppers and tomatoes, anything of that nature. It's cut at the base and the roots are left in the ground.
Yeah, I do that as well. I make sure that I just cut the plants off, etc. And but what was the mushroom, the spawn that you were putting in?
It's wine cap, King Stropharia.
Oh, the wine cap. Oh,
Yeah.
okay. Yeah, that I've been just beginning to experiment with that. Great. Wow, thanks, Paul.
Yep.
All right. Any other thoughts on that?
Monique just put a good recommendation in the chat.
Oh, awesome. Thank you, Monique. Yeah, it looks like there is a YouTube video link there. So if anyone wants to check that out.
I know Brian O'Hara is sort of like a prominent no-till farmer in the community, or minimum till, and he uses a lot of wood chips in his system, and he talks about it in his book as well. So that would be another good resource. I do use a lot of wood chips in my system, and I use them on the beds in some cases, specifically for like tomatoes and things like that as a mulch. But when I'm worried about nitrogen robbing, I've had good luck with soaking the wood chips in 5-gallon buckets before spreading them, and adding some fish emulsion to that to sort of charge the wood chips with a little bit of diluted fish emulsion to just kind of help them be charged with a little nitrogen.
One thing that I think is interesting is putting like having legume cover crops or growing cover crops like Paul's doing. That's really interesting. And all those root inputs from the cover crops and especially legumes will help make that less of an issue, I think.
Thank you. Oh, Caro, did you have something else to add?
I just had a question, but if anyone else has a question. I had a question for Paul, which is that, you know, I've seen a lot of people talking about hemp being, you know, a good biomass producer, but also a good carbon producer for the soil. I was just sort of curious about in your crop rotation. I was really interested to see the way you were sort of going vegetable, hemp, and cover crops in a rotation. I'm wondering if you have any observations from your experience, just sort of looking at the soil health after a hemp crop versus after a cover crop versus after a vegetable crop.
Yeah, that's a good question. We're in year 2, so, you know, observations at a limit. You know, like we're doing a bunch of different things. So right now I'm looking at actually, chopping the hemp crops, which we have like 4-inch calipers on the root, the base of the plants, and then inoculating those with, some type of mushroom, whether it's, I'm thinking like an oyster type mushroom, just to bring that mycorrhizate deep into the soil. Because if you do pull the hemp roots out, the root system is major and deep. So, that is a huge carbon input. But we're also taxing the soil depending on when we're planting. If you plant an early crop, the growth rate of these plants is so ridiculous that the tax of the soil is just immense. And I kind of feel like actually delaying the crop planting, you wind up with a more manageable and less risky plant. I think everybody's thoughts in the beginning was like, let's get these monster plants out there, but it's really not conducive to a business plan, because they fall over unless you stake them, put all other inputs in. So so this is the first year we're really pushing the fact. So we planted like early crops, like a cauliflower, broccoli, and then that gets pulled and that goes into a cover crop, and then we'll kind of flip flops. Is it, part of my concern, we had Cornell out there doing studies on pests, and like, are we truly in a crop rotation system if we're just moving over beds? Pest wise, the biodiversity, we also plant flowers in between beds and, release a bunch of beneficials. I think time will tell. I feel like, the resilience of our plan is there, whether long term it'll stick, I don't know. And, so it's all speculation, but the one thing we do know is that, if we're putting like leguminous crops in, we're seeing just brighter, greener plants, right off the get-go. So, and that's, if you could put, from an economic standpoint, if you could put $5 a seed on a bed and provide the nitrogen, it starts to make sense. I don't know if that answered anything, but.
Did that satisfy your question, Caro?
Sounds like we need a little longer time frame of these practices in place to be able to see the kinds of differences that I'm curious about. So I'm excited to be able to check in with you guys later after you've been collecting this data for a while.
Yeah, we have reached 7 p.m. I'm happy to stay on for a couple more minutes. I don't want to keep everybody too late though. I do want to just mention that we will have some winter conference workshops coming up in January. Caro will be presenting more on the carbon proxy protocols. I believe you have 2 workshops. And then Sarah, who is not here today, she is our livestock and dairy coordinator. She will also be presenting on the carbon proxy protocols, more focused on dairy livestock. So there's more opportunities for discussion and to learn there. We are working with Caro and her team and some of the other NOFAs to build out a lot of the resources that are coming out of this. So especially when it comes to management recommendations. So we'll be working on that over winter. So stay tuned and look out for that. If you're not already subscribed to our e-news, we do share a lot of those resources each month with you there. So I think maybe we can't have time for one more question. Does anyone have a final question? All right. Well, then we will just.
Can I ask one?
Oh, sure. Absolutely.
All this information is fantastic for the farmer to improve their production and learn about their farm and so on and so forth. I don't have to tell you anything about it, I'm wondering, is there a way that, is anyone developing a way that farmers can get more credit for what they're doing to help with ameliorating climate change by drawing carbon down? I mean, these tests tell us how to manage the farm more efficiently and how to really understand what's going on in the ground. But I'm also wondering, is there anyone working on that other aspect, which is, I've read that if all the agriculture in the world turned to regenerative agriculture, we wouldn't have climate crisis. So it'd be good for our fellow farmers if we could sort of make that more well known in the general population and actually document it somehow. Is anybody working on that?
Kiss the Earth is out on Netflix, but
I love that.
So it's a lot of stuff I've seen and heard before, but it's good that a celebrity is pushing it out there. And actually some of the folks that were at the NOFA Dairy Conference were featured on there. But it's just a great, and actually seeing the overheads of the world from a satellite and seeing the release of carbon during like April and May when they're tilling is pretty persuasive stuff in that argument.
Yeah, visually, I agree. I'm just wondering, is there a scientific proof being worked on that we can, really hang our hat on and prove that we're doing something really good?
The short answer is yes. It's happening in a lot of different places, in a lot of different institutions. Cornell has been a big part of that work. A number of other organizations and entities, and NOFA's been working on it in our own way. So short answer to the question is yes. The detailed answer would be longer than we have time for right now, probably.
Thank you.
All right. Well, and Phil, I know that you know Elizabeth Henderson, and she is working on some of these things. I've been catching up with her. We're diving into this has really pushed me to work on the policy end a little bit more. So I'm trying to become a little bit more educated about where I can take action myself with all this information. So thank you for that reminder as well. It is important to link the practice to the policy. All right, well, I think we will leave it there since we're a few minutes over. And thank you so much for everyone who has been involved with this project. It has been going on for months, and it's been a pleasure to visit everyone's farms and to share this with you all. I did put the link to the survey. It's a very, very short survey. Give us your thoughts, and so we can continue to incorporate that into these webinars and other ways of sharing information in the future. So thank you all so much. Have a good night.